All right, we're back here at Moment Machine, and we're talking some 2800 stuff. So what I put up here is the baseline flow, which is in red, and it was about 125 or 26. And what I thought was interesting, and I wanted to put up, was all three ports. You know, as you know, the ports in this head are all different, but modified up, you know, they're actually pretty similar. So the three ports above it are all three different ports modified. So I actually thought that was pretty acceptable for three completely different ports, was, you know, to get them that close. But what we're going to do is we're going to go in the other room, and I made port molds of all of them so we can kind of look at them all real quick. All right, so we're in here. We got some port molds laid out. If you watched any of the porting videos, we started on the end cylinder, the most crooked bent port, I call it. I guess it would be number 1. But it's the one we worked on the hardest because, you know, when you have the most dog legs like that, it's going to take you the longest to figure out. But, you know, this actually here had some porting on it, but we were getting a lot of stalling. We figured out the guide boss was really big, so we started to chop that down. You can kind of see the evolution. When you poured on them, they have a real square corner. They have a big dead area up by the guide boss. So in the later iterations, we actually put a little epoxy in there after we shaped it, just to kind of smooth that out, you know, so it started looking like a real valve bowl. So you can kind of see the evolution. This one is the final one. This is the one that's in the head right now. And it's really similar to this one. It just had a few other tweaks. We found a couple little things. But, so then this is the center port. And it's got the, you know, the entrance where the manifold bolt clearance is. And then this is the straightest one, or the most normal one. This port, believe it or not, I would say is the most like this one sectionally. This port here is a little bigger, a little wider up in the middle. I don't really know why. But like you saw, once you get them all modified up pretty similar, dimensionally in the short turn and the guide boss, they don't flow that different. This is the exhaust port. I know the old exhaust port's pretty crazy, but we took a picture of this thing, or not a picture, I took a mold of it. Thought it was, I just put some plugs down here. But yeah, what this is, this whole shape is an early attempt at anti-reversion techniques. And so what they did is they shaped the port, you know, to flow outward. And then anytime you get a pulse or energy leave something, you get a negative and you get a reverse wave come back. So, you know, it's pretty obvious to see that when the reverse wave comes back at the engine, they were trying to divert it away from the valve bowl. And you know, because you can get, you know, especially at low speeds, you can get contamination. You can get fresh air and fuel out in the exhaust, and you can get exhaust up in the intake tract during overlap, especially at low speeds before the engine really gets into tune. So, yeah, so we can kind of look down in here, and you can probably see just some of the little bit of epoxy. That's a splash zone. That was put beside the guides. That's kind of what the exhaust port looks like. There's better light here, so you can see this one better. And, you know, and that's the end one. So that's kind of what they look like. You know, you can see the inside and the port visually, and kind of see the molds that are coming off. The 2.9 valve is the one that we found worked the best. We did try, I don't know if this is a Rev, might be, but we did try a 12-degree valve earlier on in our flowing that was 2900 size, and we just noticed that it flowed pretty well in the low and the mid lifts, but it didn't carry high lift flow as well as the steeper tulip of the OEM, so we just stayed with the OEM. I think the aftermarket one was 12-ish, maybe 13, 14, something like that. But it did okay, but the stock ones just did better. And actually, these three valves here, which are all the same valve, we ended up moving the valve job to the center, not toward the outer edge, but more toward the center, and then cutting the 1 more degree with the grinder, cutting this to 21. And we saw a couple CFM in that. So, but that's really not typical of wedge engines at all. I mean, typically something like this, if you work on a Ford, Chevy, Chrysler, V8s, 12 degrees and stuff in that neighborhood almost always do better. And that was kind of why I grabbed it in the first place. But as we kind of started to beat the thing up and try stuff, it really prefers stuff closer to 20 degrees. So that was kind of an eye-opener. So in the some of the stuff we've been talking about online, we've been talking about using the Subaru rod, and that's what we're going to do. It's the same length as the 2800. It has a 2 millimeter smaller rod bearing, so it's going to allow us to offset grind the crank a little bit. But it's just superior in strength. I mean, chromoly H-beam, versus the stock rod, it's like, and the problem is, a lot of the labor and the machine costs are going up right now. The things are getting expensive. Just to take this rod, resize it, put ARP bolts, magnaflux it, do all, the hot tanking and cleaning. If you want to shot peen them, I mean, you're going to have $300-400 doing that. I think I bought both of these. I had to buy 2 sets because they're 4-cylinders. But I think I bought 2 sets, 8 of these rods for $600. And, they have 3/8 ARP 2000 bolts. I mean, they're brand new. So it was just like, yeah, I'm going to go that route. And then the last thing we were talking about was ring package. This is the stock piston, and you can see the factory rings. This is a little more modern piston of the same bore, but this is just kind of what 30 years of ring technology will get you. These thinner rings just have less drag. They conform to the bore better. They seal better. It's just something, that to me is a no-brainer. So, but yeah, it's kind of an update, just kind of a look at some of the parts and pieces. And then I got these from RPM International, and I think they're going to have a good deal on these for a while, but I don't know if they're going to keep doing that. So, I mean, if any of you guys are interested in trying, some of these rods, you might want to talk to those guys pretty quick if you still want a pretty decent deal on them. So yeah, that's about it. I was thinking, I've got that article that I posted up, and I kind of stapled it together like a magazine. There was a couple things I was going to talk about, the timing, gears. I'm going to use an aluminum one for sure. I think that the new ones are stronger, and this is a weekend warrior car. We're not going to go 1,000 miles wide out and then pitch it in the trash. Yeah, I mean, the stock manifold, I think he points out, that the fuel distribution on this, that's actually one thing I was going to talk about, is fuel distribution is going to be kind of a key thing to making this old carbureted engine run better, because that's something new engines, when you have a fuel injector per hole, fuel distribution isn't an issue. But, like the aftermarket manifold that's out there, fuel distribution, I from my testing so far, is a pretty big concern on that manifold in particular. And I think that's one of the reasons that these guys ended up modifying the stock one. You know, I think it just was a simpler design, maybe had a little more momentum and inertia with just one consistent runner. But I think what you're going to find is that this manifold actually had better fuel distribution. If you look at that offie, the center runner's got a really big detent near the floor, and it's going to have a real issue wanting to favor that center runner. And I think you're going to find out that manifold starves 1 and 6. I'm actually going to do some more testing on that. But yeah, this article I thought was pretty cool. Saw it years ago. And 200 horse is the goal for what we're building. But we're handicapping ourselves, right? We want to run less compression. We want to run 10.2. So we're going to start out 1.5 points lower. And we want to run a smaller cam than they did because we don't want to run it at between 6,500 and 7,000 all the time. We want to drive it around. So, you know, we're going to definitely have to, you know, that's part of the reason we're figuring the heads out pretty hard. Looking at things like modern rings, because we want to make the 200 horsepower, but we want it to be more drivable and street friendly. So, and I'm not sure, you know, I know that they definitely did work on the heads and stuff on this engine, but 40 years ago, flow benches and stuff, they were around, but they weren't real commonplace yet in a lot of shops. They might have had a flow bench, I'm not sure, but, you know, there's a part of the article where he talks about the Manley valve having a better flowing shape than the stock unit, and from what I've seen on the flow bench, I don't think that's real true. So kind of leads me to believe that they were doing most of their work without the flow bench. But we're not. We're definitely beating it up pretty hard. So anyway, this is just a quick look at what we're doing and some of the parts and why we're doing it. But as things go on, or as time goes on, we'll talk about it more. The crank's out of the grinders, and I've just putting together a spec sheet to get the pistons going right now. So I got the block, but I got to go get it out of the bag, and I don't know if looking at a block with honed cylinders is like super interesting or not. But anyway, we got a lot more to do, so we'll talk to you guys later.